So today we'll discuss about even signals and odd signals. Okay. So a continuous time signal is said to be even signal if it satisfies the condition x of t is equal to x of minus t for all the values of t. Okay. So a continuous time signal is said to be even signal if it satisfies the condition x of t is equal to x of minus t for all the values of t. Okay. So a continuous time signal is said to be odd signal if it satisfies the condition x of t is equal to minus x of minus t. Fine, for all the values of t. So this is a definition for even and odd signal. So a continuous time signal x of t is said to be an even signal if it satisfies the condition x of t is equal to x of minus t for all the values of t. Similarly, you call a continuous time signal as an odd signal if it satisfies this condition x of t is equal to minus x of minus t for all the values of t. Okay, this is about continuous time signal. Coming to discrete time. So a discrete time signal is said to be even signal if it satisfies the condition x of n is equal to x of minus n for all the values of n. Okay. Similarly, a discrete time signal is said to be odd signal if it satisfies the condition x of n is equal to minus x of minus n for all the values of n. So we shall see what is x of minus t and what is x of minus n. Okay.
Ma'am, this
So
comes under deterministic and random signals, no?
no. This is a different classification of signals. Deterministic and random is over. Okay, just you have to know what is deterministic and random. That is over. Next
Okay, ma'am.
classification is even signals and odd signals. That is over. We are discussing about different classifications of signal. Okay, first what we have seen continuous time and discrete time. That is basic classification. Okay, discrete time and continuous time, right? What was the second classification? Periodic signals and non-periodic signals. So this discrete time, continuous time is basic classification. Okay, discrete time is x of n and continuous time is x of t. Okay, periodic, non-periodic, we have seen the problems. Next, what else we have seen? We have seen deterministic random. So next classification is even and odd signals. Next we have energy signals and power signals. Got it?
Yes, ma'am.
We are discussing about even signals and odd signals now. Okay, some are different classification of signals. So this is over. These three types we have seen. So in this course, you will be analyzing both continuous time signals as well as discrete time signals. Okay. So periodic and non-periodic might be discrete time or continuous time. Similarly, deterministic and random, you have to know the definitions for this. This is just for your information. And even and odd also will be solving problems with respect to discrete time and continuous time, like how we solve for periodic and non-periodic. Okay. Similarly, have energy and power signals also. For that also, you'll be solving problems. Okay, you'll be finding energy of a signal and power of a signal. So that is about even signals and odd signals. So these even signals, no, they are symmetric about y-axis. Symmetric about y-axis or your vertical axis. Okay. Whereas odd signals, they're anti-symmetric about y-axis or vertical axis. This you have to keep it in mind. Odd signals are anti-symmetric about y-axis or vertical axis. Okay. So before going to even signals and odd signals in detail, we shall discuss about an important topic called time reversal. So I have explained you about time reversal in last semester. I hope you remember. I'll brief up time reversal. So what is time reversal? Does anyone remember? What is time reversal? If you have x of t, time reversal is x of minus t, correct? If you have x of n, time reversal is x of minus n. You remember this? You don't remember this? I'm asking you people, do you remember this time reversal concept? Yes or no?
Yes, ma'am.
So we shall discuss about time reversal. If you don't remember, it's okay. So time reversal is nothing but mirror image of the signal about y-axis. Okay. It's a mirror image of the signal about y-axis or vertical axis. Okay, it is nothing but folding or reflection. Another name of time reversal is folding or reflection. Suppose I'll give you an example. You have a signal x of t like this from 0 to 3. This is time axis. This is amplitude is 1 for this. So what is the mirror time reversal of this signal x of minus t? What is the mirror image of this signal? You fold this signal about y-axis. Okay, this is x-axis, this is y-axis. Fold this signal. If you fold it, from where to where will the signal exist?
-3 to 0.
Yes, it will exist from -3 to 0. This is called time reversal, folding or reflection. Okay, time reversal is nothing but mirror image of the signal about y-axis or vertical axis. Okay, we are folding the signal about y-axis to get the mirror image of the signal. So now I'll tell you what is even signal. So if we perform time reversal, we have performed time reversal here, right? So if we perform time reversal based on the symmetry of the signal, if the signal remains the same, then it's called as even signal. Okay, I'll repeat once again, listen. If we perform time reversal based on the symmetry of the obtained signal, if the signal remains the same, then it's called as even signal. Understood what is even signal? So if we perform time reversal based on the symmetry of the obtained signal, if the signal remains the same, then it is called even signal. What did you understand from this? Tell me what you have understood from this sentence.
X of t is equal to x of minus t.
Yeah. So if we perform time reversal based on symmetry of the obtained signal, so I have performed time reversal for my x of t and it is symmetric. Okay, after I perform time reversal, I can observe that this signal is symmetric about y-axis. If this is symmetric, then it is called as even signal. Okay. So that means if x of t is equal to x of minus t for all the values of t, then the signal is called as even signal. Understood what is even signal, everyone?
Yes, ma'am.
I'll give you one more example for even signal. Suppose you have a signal like this. X of t, is it even signal? X of minus t, you'll get like this. It is symmetric, right? It is symmetric. Suppose it exists from 0 to some 1. This exists from 0 to -1. Is it symmetric? Yes, it's symmetric, right? It's a mirror image. If you fold this signal about y-axis, you'll get this signal. So it's symmetric and it's called even signal. Okay. So one more example. Can I take cos theta or cos omega t? Cos omega t. Okay. So what is so cos of minus theta? What is cos of minus theta?
Cos theta.
It's cos theta only, right? So if x of t is equal to cos omega t, x of minus t is also cos omega t only. So this is also best example for even signal. Okay, this is an even signal. Your cos theta is an even signal. Okay, so you can take down a note that even signals will remain identical under time reversal or time folding or reflection. Okay, you take down a sentence. Even signals remain identical under time reversal or reflection or folding. We call time reversal as reflection, right, or folding, right? So even signals will remain identical under time reversal or reflection or folding. Okay, so coming to odd signal, even signal, it's clear for everyone.
Yes, ma'am.
Okay, coming to odd signal, the signals which are not identical under time reversal are called as odd signals. Okay, signals which are not identical under time reversal are called as odd signals. So here x of t is not equal to x of minus t. Okay, so x of t is equal to minus x of minus t. So what is this? This is the equation for odd signal. So the signals are anti-symmetric about y-axis. Okay, you can say that the signals are anti-symmetric about y-axis. Okay, odd signals are anti-symmetric. So you can write the equation as x of t is equal to minus x of minus t, or x of minus t is equal to minus x of t. This is the equation for odd. Okay, equation for odd signals. So I'll give you an example. Suppose this is my signal x of t, which is existing from 0 to 1 with amplitude 1. So what is minus x of minus t? So first we have to plot x of minus t. Okay, so x of minus t, how will it look? It will be opposite, right? Minus 1 to 0 with amplitude 1. Now I'll do minus x of minus t. This is time reversal. This is amplitude reversal. So as of now, you understand this much. When we discuss about operation of signals, we'll discuss about amplitude reversal, time shifting, amplitude shifting, and all in detail. Okay, amplitude scaling, time scaling, we'll discuss about those topics. As of now, you understand this much. So this is minus x of t. So minus x of minus t will look like this. Okay, it will be like this. So this is minus 1, this is also minus 1. Got it? So compare x of t and minus x of minus t. X of t is equal to minus x of minus t for odd signal. As you can see, x of t is anti-symmetric about y-axis. X of minus t, minus x of minus t with respect to x of t. Yes or no? This is symmetric and this is anti-symmetric. Are you people following?
Yes, ma'am.
Everyone clear?
Yes, ma'am. Yes, ma'am.
So this is x of t. I want minus x of minus t. So I will take first I'll draw x of minus t. Okay, then minus of x of minus t. So amplitude will get reversed here. Okay, your signal will look like this. So this is called odd signal. Okay, they are anti-symmetric about y-axis. And I'll give you one more example. You can consider sine omega t. X of t is equal to sine omega t. Because sine, what is sine of minus theta? It is minus sine theta. Correct? So x of minus t is equal to minus sine omega t. Okay? So x of minus t is equal to minus x of t. This is one example of odd signal. Best example of odd signal is sine theta. And best example of even signal is cos theta. Okay? Is it clear, everyone? Odd signal and even signal?
Excuse me, ma'am.
Yes.
Ma'am, but above we have written that x of t is equal to minus x of minus t, right, ma'am?
Yeah, this equation also holds good, and even this also holds good. Both are same. Okay?
Okay, ma'am.
Yeah, one more equation. Both are same. But this is an equation for odd. We can also represent odd signal like this. Okay?
Okay, ma'am.
So clear, everyone, what is even signal and what is odd signal? Even signal will remain identical under time reversal. Okay? But odd signals are not identical under time reversal. Clear? Understood, guys? What is even signal and odd signal?
Yes, ma'am.
Okay, we shall see some equations for even and odd signal. So any signal you can represent as a sum of even signal and odd signal. Okay, so any signal you can represent as a sum of even signal and odd signal. I will take x of t as x e of t plus x o of t. Okay, this is even signal, even part of the signal. And this is called odd part of the signal. So any signal we can represent it as a sum of even signal and odd signal. Okay. So continuous time signals can be represented as a sum of even signal and odd signal. Right? Take this as equation 1. Okay. X of t is equal to x e of t plus x o of t. This is your equation 1. Okay. Now, what is time reversal of this signal x of minus t?
X e of minus t plus x o of minus t.
Yeah, x e of minus t plus x o of minus t. So, what is even formula for even signal? Condition x of t is equal to x of minus t. Right? Can I write x e of t as x e of t only, x e of minus t as x e of t only? Condition for even?
Yes, ma'am.
So I will write x of minus t is equal to x e of t only, because it is condition for even signal. Okay, x of minus t is equal to x e of t plus, or I'll take minus x o of t. Okay, condition for odd, x of minus t is equal to minus x of t, or x of t is equal to minus x of minus t. Condition for odd signal, correct? So I have taken x of minus t as x o of minus t as minus x o of t. Clear? Now take
Yes,
this as equation 2. So what have we done first? Any signal we can represent it as a sum of, any continuous time signal we can represent it as a sum of even signal and odd signal. So x of t is equal to x e of t plus x o of t. Okay, take this as equation 1. Now time reverse your continuous time signal x of t. Okay, you get x of minus t. So wherever you have t, replace it with minus t. Okay, x of minus t is equal to x e of minus t plus x o of minus t. Now, according to our condition of even signals, x of t is equal to x of minus t. That is the condition for even signal. So, x e of minus t, I write it as x e of t only. Okay. And condition for odd signal is x o of minus t is equal to minus x o of t. Okay. So, this is my equation 1 and equation 2. Now, we have to find the even component and odd component. Okay. So now to find the even component and odd component, you have to add equation 1 and equation 2 to find the even component, and you have to subtract equation 1 and equation 2 for finding the odd component. So first what you do is you add equation 1 and equation 2 to find even component. Add equation 1 and equation 2 to find even component. You add and tell me what you get. Add equation 1 and equation 2. X of t plus x of minus t. I am adding LHS, which is equal to RHS, that is xe of t plus xo of t plus xe of t minus xo of t. So xo of t, odd part will get cancelled. So x of t plus x of minus t is equal to 2 times xe of t. That is even part of the signal, twice even part of the signal. So if I want xe of t, I'll shift the 2 to the other side. Xe of t is equal to x of t plus x of minus t divided by 2. Okay, this is the equation for even part of the signal. Okay, this is very important. You'll be using this to solve signal waveforms and all for even part and all. Okay. Clear, everyone?
Yes, ma'am.
To find the even component of the signal, that is xe of t, equation for xe of t, I'm adding equation 1 and equation 2. So LHS I'll have x of t plus x of minus t. Similarly, I'll add RHS also, xe of t plus xo of t plus xe of t minus xo of t. So xo of t and xo of t will get cancelled because you have plus and minus sign. So you're left with x of t plus x of minus t is equal to 2 times xe of t. Okay, 2 times even part of x of t. So xe of t is equal to, put this 2 to the other side, you get x of t plus x of minus t by 2. Okay, if I ask you the equation to find the even part of the signal, you have to tell me this equation. It's x of t plus x of minus t by 2. Similarly, we'll try to find the odd component. Okay, to find odd component, subtract equation 1 minus equation 2. To find odd component, you subtract equation 1 minus equation 2. So what do you get? X of t minus x of minus t is equal to xe of t plus xo of t minus xe of t plus xo of t. Correct? I have multiplied this negative sign. Got it?
Yes, ma'am.
Others followed? You want me to write that step? Xe of t plus xo of t minus xe of t minus xo of t. I have skipped that step. Minus xe of t plus xo of t you will get. Clear? Now, which you can cancel, xe of t and minus xe of t you can cancel. So x of t minus x of minus t will give you 2 times xo of t. Correct?
Yes, ma'am.
So what is your odd component, equation for odd component of the signal?
X of t minus x of minus t divided by 2.
Yeah. This shifted up equation 2. Okay. So xo of t is nothing but x of t minus x of minus t by 2. So this is the equation for finding the odd part of the signal. Okay, these are important. Understood? To find odd component, equation for even component of the signal and odd component of the signal. Clear? Here for
Yes,
even
ma'am.
component xe of t, you have x of t plus x of minus t. What is x of minus t? Time reversal of x of t. Okay, you have to, for finding even component, you have to add original signal with its time reversed signal and divide it by 2. You'll get even part of the signal. Okay, For finding odd part of the signal, you have to take continuous time signal x of t, subtract that with time reversed continuous time signal, that is x of minus t, and divide it by 2. You'll get odd part of the signal. Clear, everyone?
Yes, ma'am.
Clear?
Yes, ma'am.
So similarly for discrete time signal, so this is for continuous. For discrete time signal, x of n, we can obtain even component xe of n and odd component xo of n. Okay, x of n, it's the same. Okay, instead of t you have n. X of n is equal to sum of xe of n plus xo of n. Okay, so even part you add, you take time reversal of this and add equation 1 and equation 2, you get xe of n, which is equal to x of n plus x of minus n divided by 2. This is even component of the signal, of discrete time signal. Okay, this is important. Make note of this. And you have xo of n. Same way how to do, like how we did even. Okay, like continuous, how did we did continuous, same part you follow. For this you get xo of n as x of n minus x of minus n divided by 2. Clear, everyone? This is odd part of the signal, odd component of discrete time signal. This is even component of discrete time signal. Followed?
Ma'am, in continuous signal, t represent time period, right, ma'am?
Yes. T
In
is
discrete n means, ma'am?
n means samples, number of samples. That is also time period with respect to n. X of n. This is n here. For discrete, this is for continuous. You have x of t, and this is time. This is n samples. This is time period. Time. N is also
Okay.
time only, but we tell it as samples. Okay.
Okay.
Yeah. Clear, everyone? Even part, odd part. We shall solve one problem. Take down. Find the even and odd component of the signal or the given waveform. So take down the signal. You have x of t and you have a signal here, that is 2, and amplitude is a, and this is time. So what are the equation for even component? Tell me the equation for even component of the signal.
X of t minus x of minus t divided by 2
X of t,
plus x of minus t
yeah,
divided
plus x of minus t divided by 2. That is even part of the signal. Coming to odd part of the signal, what is the equation?
x of t minus x of minus t divided by 2.
Yes. So now what you will do to find even component and odd component? So first you will take mirror image or time reversal of x of t, then add it and divide it by 2. Okay. For odd component, what you will do, you will take mirror image, subtract that mirror image from the original image and divide it by 2. Shall we start doing?
Yes, ma'am.
Yes, ma'am.
Yeah. So far you write x of minus t. So this is my x of minus t. It is from 0 to minus 2 with amplitude a. Now I want to find x of t plus x of minus t. X of t plus x of minus t. By 2 I will do next step. Now you tell me what to do. At 0, what is the signal? Compare both the signals. Okay.
0.
At 0, it is 0 only. At 2,
A, ma'am.
so add these two. Here you have 2 here, a here, and here you have 0 at 2. So a plus 0 is a only, right? Yes or no?
Yes, ma'am.
Yes, ma'am.
That is A only. Now this side, we have to add this side. So here we have 0 and here we have A. 0 plus A is at -2.
A, ma'am.
0 plus A is A only, right? So here also you have A. So this is x of t plus x of minus t. Got it?
Yes, ma'am.
Everyone got it? See,
Yes.
at time t is equal to 2 to t is equal to -2, you have to add these signal. Okay? If you see, you have amplitude A for this signal and for this also amplitude A, but time period for the signal is 0 to 2, whereas for time reverse signal is 0 to -2. If I tell you to add these two signals, you take 0 to 2. So at 2, what is the signal? It is A. And compare this signal. At 2, what is this signal? It is 0. So A plus 0 is A only. Okay, so we have got A. Similarly, at -2, here my signal is 0. 0 plus A is A only. So at -2 also you have A. Clear?
Yes, ma'am.
Now we have to get the even component. Our work is not done. We have one more step here. We have x of t, that is xe of t, which is nothing but x of t plus x of minus t by 2. Now amplitude is a here. So we have by 2. So amplitude will be a by 2. That's all. Okay. Your signal will exist from 0 to 2 and 0 to -2 with amplitude reduced a by 2. Got it? Even part? Followed?
Yes, ma'am.
Amplitude you reduce by 2 because it's divided by 2, right? So amplitude reduced by 2. So you get a by 2. Suppose your signal is 2 here, it will become 1. Amplitude will become 1. If it's 1, amplitude will become 0.5. Clear? This is the even part of this signal. Got it?
Yes, ma'am.
Okay. Now we will see what is odd component of the signal or odd part of the signal. Okay. So I will draw here x of t minus x of minus t. So you subtract this minus this you do. So what do you get? At 0, the signal is 0. 0 minus 0 is 0 only. At 2, what you have? A. A minus 0 is
A.
A itself. Okay. At 2, you have A itself. One minute. At 2, we have amplitude A itself. Now compare at -2. What is amplitude at -2? What is amplitude at -2 here for x of t? 0. 0 minus A. What is 0 minus A?
Minus A.
Minus A. Okay. So this signal will be like this. This is minus A. Got it? So you have this minus A here. Understood? See here. At 2, at 0, 0 minus 0, we have 0 only. At 2, A, you have amplitude A. And here, for x minus of t, at 2, you have 0. So A minus 0 is A only, so amplitude is A. Whereas at -2, you check. At -2, you have 0. And for x of minus t at -2, you have A. So 0 minus A is minus A. So amplitude is minus A. Got it?
Yes, ma'am.
Now we have to find odd component, right? What is odd component? X of t minus x of minus t divided by 2. Okay, so what happens here? Amplitude will be reduced to a by 2 instead of a. Okay, so the signal will be at -2 to 2 with amplitude a by 2. Got it? Suppose if your amplitude is 2, you will have a signal from 1 to 1. Okay, if a is 2 and minus a is -2, then odd component will be from 1 to -1. Sorry, it is my a by 2 to minus a by 2. This is minus a by 2. Minus a by 2. Got it?
Yes, ma'am.
Understood, guys? So these are some simple waveforms. So you will be having waveforms like this. Clear, everyone? So I'll brief up once again. Whoever didn't understand, just try to understand. So given this signal x of t, you have to find the even component of the signal as well as odd component of the signal. So we know what is the equation for even component of the signal. It is x of t plus x of minus t by 2. Okay. Whereas for continuous time, this is continuous time signal, right? The odd component is x of t minus x of minus t by 2. So as given in the equation, we have to add a signal with its time reversed part of the signal and divide by 2 to get xc of t. So first approach of this problem is you have to take the mirror image of the signal. Okay, if you have x of t, take time reversal of that signal or mirror image of that signal, that is x of minus t. First you draw x of minus t. Okay, after drawing x of minus t, then you add x of t plus x of minus t for even part. Okay, don't divide by 2 first step only. First you add it, x of t plus x of minus t you do. So if you add these two from 0 to 2, here you have a, you don't have anything here. A plus 0 is a only. And here you have 0, 0 plus a is a only. So you get this signal. Okay, x of t plus x of minus t. Then we are not yet completed. We have divided by 2 for even component. So if you divide it by 2, amplitude will get reduced to half. Okay, so this is your even part of the signal. So you can observe here, even part of the signal is symmetric about y-axis. Correct? Yes or no? This is my y-axis or vertical axis. Your signal is symmetric, right?
Yes,
Yes,
ma'am.
ma'am.
Understood, everyone? Now
Yes,
we
ma'am.
will see what is odd part of the signal. It is x of t minus x of minus t by 2. Okay. Now you have to subtract x of t minus x of minus t by 2. First we'll do x of t minus x of minus t. So this is my x of t. You would have drawn the x of minus t before only, right? So no need to draw again. So make use of that only. So at 0 you have 0 minus 0, 0 only. So at 2 you have a, and here at 2 you have 0. So a minus 0 is a. So I have at 2 I have a amplitude, whereas at minus 2 I have 0. Amplitude is 0. My signal is only from 0 to 2. At 2 my signal is 0. Okay, I don't have any waveform here. It is 0. So 0 minus, for x of t you check at minus 2 what you have. So 0 minus a will be minus a. Okay, so amplitude will get minus a. So now we are not yet completed. So divided by 2 in next step. So you get a by 2. A signal will exist from a by 2 to minus a by 2. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I'll give you one signal. You try that. Okay. Second question. Find the even and odd part of the waveform. So my x of t is this. X of t is a signal, this, and here I have a signal from 0 to minus 2. Middle I have minus 1, this is minus 2, this is 0, and this is 1. And this is my time axis. Try doing this. 1, 2, so on. This is my x of t. So try doing this even in odd part of the waveform. So what is the equation for even part? Xc of t is nothing but x of t plus x of minus t divided by 2. And equation for odd part is, yes?
Ma'am, what is the amplitude value, ma'am?
It is 1. Okay. Amplitude is 1. xo of t is x of t minus x of minus t by 2. So first step is how to write the equations. Okay. Then you have to draw the mirror image of the signal x of t. Okay. What is the mirror image of the signal? Whatever is there in the left will go to right. Whatever is there at the right will go to left. Okay. So x of minus t would be, see in the left side I have signal from -2 to 0. That will go to the right side. Okay. So I have a signal from 0, 1 and 2. 0 to 2 I have here. Again here from -1, the signal will look like this. This is a mirror image of the signal. Yes or no? This is 2. It goes on. This is not never ending here. Okay, it's going on up to infinity. Here also it will go on up to minus infinity. Minus infinity to 0. Here 0 to infinity. Got it?
Yes, ma'am.
Yes, ma'am.
Now you try to plot the even part and odd part. Now first step what you will do, you will add, right? X of t plus x of minus t do. Okay. So x of t plus x of minus t. So how will you do? So amplitude is 1 here. Okay, this amplitude is 1. So at 0, what is your signal? At t is equal to 0. This is time axis. Okay, time axis for both x of t and x of minus t. At t is equal to 0, you check first. At t is equal to 0, it is 0 only. So 0 plus 0 is 0 only. So at 0, your signal will be here at 0. And at 1, what happens?
1 only.
Check once. The signal is at 1 here.
Amplitude is
2, ma'am.
Yeah, it will be 2, right? See here. At t is equal to 1, x of t amplitude is 1. Whereas x of minus t amplitude is also 1 here. So 1 plus 1, you will have 2. Correct? Guys, following?
Yes, ma'am.
Similarly, x of minus 1 you see. At x of minus 1, what is the amplitude? For both x of t and x of minus t, 1. For x of minus t, amplitude is 1. For x of minus t also at minus 1, amplitude is 1. Correct?
Yes, ma'am.
Yes, ma'am.
So at minus 1 also it will go to 2. This is 1 amplitude, this is 2. Then you see at 2, what is happening? 2 and minus 2. First you check at 2. So at 2 here, the signal is 1. Correct?
Yes, ma'am.
At 2 here, what is the signal?
0, ma'am.
So at 2, it will come back to, where it will come back?
1.
1.
1 plus
1.
0, 1. Correct? So at 2, your signal will be at 1. Got it?
Yes, ma'am.
At 2, the signal is at 1. Okay? This is 2 and the signal is at 1. Will you agree?
Yes, ma'am.
Yes, ma'am.
Okay, now you see at minus 2. At minus 2, it is a 0. 0 plus 1 is 1. Here also it will come from minus 1. At 2, it will come back to 1. Got it? Next,
Yes,
at
ma'am.
3, you see. At 3. And minus 3. So at 3, what you have? 1 plus 0. What is the signal at 3?
1, ma'am.
So it will go on like this. 3, 4, so on. It will go on. Okay? Got it? Similarly, the other side also. 0 plus 1 is 1 only. So at minus 2, it's 1. At 3 also, it's 1. Then again, you have 0 here. 0 plus 1, it's 1 only. At minus 4 also, it's 1. It will go on. Even at right side also, at same. Here at 4 it is 1, at 4 it is 0, 1 plus 0 is 1. Got it?
Yes, ma'am.
Understood everyone?
Yes, ma'am.
So are we done with even component of the signal?
We
No,
have
ma'am,
to do
divided by two
divided
we have.
by 2.
We have to divide by 2, right? So we have x of t plus x of minus t divided by 2. Okay? So at 1 and at 2, at minus 1, at minus 2. Okay? So my signal which was at 1 will become 0.5, and which was at 2 will become 1. Okay? So the signal will look something like this. Clear everyone?
Yes, ma'am.
Yes, ma'am.
Understood?
Yes, ma'am.
Now you plot odd part. Understood everyone? You'll get such type of problems only. Is it clear? You have to check the amplitude at each instant and you have to plot it. Okay, now you go to odd part. X of t minus x of minus t you do. Clear everyone, even part of the signal?
Yes, ma'am.
Okay, now go to odd part. X of t minus x of minus t you do. You subtract x of t from x of minus t and see what you will get. So I will write here. So I have x of t minus x of minus t. So at 0, what is at time instant 0, t is 0, what you have? 0 minus 0, it is 0 only. And at 1,
0, ma'am.
1 minus 1, it is 0. Okay, so the signal will be 0. Okay, it will be 0 only. Next, at 1 to 2, what happens? At 2, what is the
Ma'am, it
signal?
will become 1. 1, ma'am.
At 2, the signal will become 1. Correct? Next, at 3, what happens?
1,
1 minus 0,
1,
1. Okay, again at 4,
1,
1 only, right? That will continue. 4, 5. Next, you do the next part. At minus 1, what happens to the signal? At minus 1, what you have? T. At
0,
t is
ma'am.
equal to minus 1, you have amplitude 1 and here also 1. 1 minus 1, it will be 0. Okay, it will be 0. Next, at 2, minus 2, you have 0 minus
1,
1. So how will your signal look? From minus 1 to 2, it will be minus 1. Okay, this is minus 1 and this is plus 1. So at minus 3, what happens?
minus 1 only.
See here, at minus 3, you have 0 and here at minus 3, you have 1. So 0 minus 1, 0, amplitude here is 0, here it is 1. So we are subtracting x of t minus x of minus t. So 0 minus 1 would be minus 1 only. Okay, so it will continue. Got it? Odd part. So we have for xo of t, x of t minus x of minus t by 2. So I'll do half here, minus half and plus half. Got it? You don't change there only, you draw again xo of t and change the amplitude. Clear everyone? Guys, it's clear?
Yes, ma'am.
Everyone, is it clear?
Yes, ma'am.
Okay, guys. Understood? You want me to explain once again? You want me to brief up once again? Yes or no?
And brief that
Got
odd
it,
part,
ma'am.
ma'am.
Yes. So I have a signal x of t. And what is the equation for odd part? X of t minus x of minus t by 2. Okay, so I have to subtract x of t minus x of minus t. X of minus t. I have to subtract these two. At t is equal to 0, you see. T is equal to 0, t is equal to 0. 0 minus 0, it is 0 only here. Okay. And at 1, I have amplitude 1. Okay, here at 1, I have amplitude 1. So 1 minus 1 would be 0. So my signal will be 0 till 1. Yes or no?
Yes, ma'am.
Then at 2, you see, amplitude is 1 at 2. Here the amplitude is 0. So 1 minus 0 is 1. So from 1 to 2, it will become 1. Okay?
Okay, ma'am. Understood.
Okay. Again at 3, you see, 3 you have 1 and here you have 0. So 1 minus 0 is 1 only. Again at 4 also 1 minus 0 it's 1 only. Okay, and 5 also 1 minus 0 it's 1 only. At 5 also amplitude is 1. So coming to the left side, negative minus side, t negative value side. So here at t is equal to minus 1, you have the amplitude 1. And here also for x of minus t, you have 1. So we are subtracting x of t minus x of minus t. So 1 minus 1 is 0. Or minus 1 also it will be 0. Fine. Come to minus 2. Next. Okay, at minus 2, you have 0 minus 1. Here you have 1, right? So 0 minus 1 would be minus 1. Okay, at minus 2, I have minus 1. Okay. Then at 3 also it is 0 minus 0, amplitude is 0 and here it is 1. So 0 minus 1 is minus 1 only. So I want odd part of the signal, right? So x of t minus x of minus t by 2. So amplitude which was at 1, I will put it at 0.5. Okay, 1 divided by 2 I will do, or minus 1 divided by 2. Okay, this is the odd part of the signal. Got it, everyone?
Can you show that even part of signal, ma'am?
Yes. And you observe the even part and odd part. Even part is symmetrical about y-axis, as you can see, whereas odd part is anti-symmetrical about y-axis. That is your reference to verify your answer whether it's correct or wrong. Okay, it's anti-symmetrical about y-axis. See, correct? So that is how you have to verify your answer. Clear, everyone?
Yes, ma'am.
So I will give you one problem, you try that. Okay, in next class I will solve that. Monday, what time you have my class?
At 11:15, ma'am.
Okay. Take down this homework problem. Find the even and odd part of the signal. So my signal, this is x of t. So this is instance 1, instant 2, instant 3, minus 1, minus 2, minus 3. This is t. So I have a signal from, yeah, I have a signal like this. Just a minute. So from minus 2 to minus 1, I have a ramp. Then I have a step signal till 2. Again, I have a ramp at 3. So the amplitude of this is 1. You try this homework problem. Find x, even part of the signal, and odd part of the signal, x o of t. Okay, I will, if you didn't get, I will solve it in next class. You try this. And one more problem. You have x of t. So this is minus 1 and this is 1. Okay, and at 1 and this is minus 1. Yeah, from 1 to 2, I have a signal like this. This is -1. This is 2. Okay, will you try this? Find the even part of the signal and odd part of the signal. Try this first one and second one. Okay, I will solve it Monday. You can verify this. Did you all take down?
Yes, ma'am.
Okay, you try this.
Yes, ma'am.
Monday we shall solve this. You have any doubts from today's class? Is everything clear?
Yes, ma'am.
I'm sure that
Question? Yeah, you can write your name and USN in the chat box. Okay, for attendance purpose. This is the homework problem.
Ma'am, we can leave, ma'am.
Yeah, if you take, did you take down this homework problem?
Yes, ma'am. Yes, ma'am.
Okay, then we can stop the recording. We can wind up this class. Thank you, students.
thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.